In this unit, we're going to talk about materials and the different phases that they can occupy. So what are materials? Well, materials are made out of matter. And matter is anything that has mass and takes up space. So it's something tangible. You can feel matter. Matter is what the universe is made up of. And there's really only two things in the universe. There's matter and there's energy. Anything tangible we can touch, feel, that's matter. But you have to be a little bit careful when you talk about matter because you might think that heat is matter, and it's not. It's just energy. So don't confuse just something you feel as the sole classification of what matter is. It must also occupy space. So mass is what we measure matter in terms of. So gram, kilogram, milligram, microgram. We're talking really small masses. But it's some form of the gram. And what's important to know is mass is constant. So if you have a mass of 5 grams on Earth, you're going to have a mass of 5 grams in space. And the reason I bring this up is people often get mass and weight confused. They use the terms interchangeably. Weight refers to a force that gravity exerts on a mass. So you can be weightless in space, but you are not massless in space. So you always have the same mass no matter where you go. Now, materials are made up of either atoms or combinations of atoms. And we'll talk more about that in a second. Atoms are the smallest piece of matter which you can have and still be stable. So there is matter that's smaller than the size of an atom, but it's not stable. It won't be there indefinitely. And yes, there are components of the atom that are smaller, but that's because they make it up. But the atom overall is the smallest thing you can get and still be stable in the known universe, at least at the time of this video. So you can have atoms, and you want to think about atoms as being like Legos. They're the Legos of the universe. There's something like 118 different Legos we have and we know about at this point that makes up everything in the world, in our surroundings, in the universe. So it's quite an impressive feat that, from a finite number of atoms, we can create nearly an infinite possible number of combinations of these materials, which make up molecules and compounds. Now, compounds are made out of atoms which have gained and lost an electron. So they're basically materials that are held together by positive and negative charges. And we'll go into this in more detail in the next chapter or two. But basically, we have 3 types of materials in the universe. We have compounds, which are held together by charges. We have molecules, which are held together by atoms sharing electrons. And so they create what's known as a covalent bond, which will also be something we study this semester. And then we have a classification of material known as alloys, which most chemistry textbooks kind of glaze over. But basically, alloys are mixtures of metal atoms and occasionally a non-metal atom to form a metallic-like substance. So alloys you may be familiar with in terms of rims on automobiles. It's probably the best example. Stainless steel is an example of an alloy. And they're quite common. You just have to look for them a little bit in the real world. Now, when it comes time to molecules, compounds, and alloys, they exist in one of 3 states. There's the solid state, the liquid state, and the gas state. Solids are materials that have definite volume and definite structure. That is, they maintain their form regardless of what they're being held in. Liquids have definite volume but have no overarching structure. They conform to whatever vessel they're in. And gases have no structure And really, they occupy the volume of whatever it is that's holding them. Liquids still have a definite volume, they just lack structure. Gases, there's no structure, and they take the volume of whatever it is that's occupying them. So those are the three phases we typically talk about in chemistry class. There is a fourth phase of matter known as a plasma, which would be something like a sun type of setting. So very high temperature, high pressure, not anything we really deal with or see. So we're not going to focus on plasma in this course at all. But I did want to mention it briefly. Now, materials, whether they're molecules, compounds, or alloys, can make mixtures. So we can combine things. So we have two classifications of mixtures. We have homogeneous mixtures, which means that the mixture is mixed thoroughly throughout and that the composition is consistent at any given point. So you can see in the two beakers here, we've got green dye, we've got orange dye. The intensity of the color is the same no matter where you are in that beaker. That is, the concentration is the same. Everything is uniform and dispersed throughout a homogeneous mixture evenly. A heterogeneous mixture, on the other hand, things are not distributed evenly. For example, we all know that oil and water do not mix. And this is a picture of the part of the BP oil spill that happened almost a decade ago now. And we can see that the water and the oil, they're not mixing at all. And that's part of the problem. If the oil mixed in the water, it would be diluted out and it would disappear. Unfortunately, oil and water don't mix, so the oil just kind of spreads all over the place, but it doesn't actually ever dissolve. And so you can have regions of the ocean where there's more oil than water, or all oil and no water, or all water and no oil. Another way of thinking about this might be if you want to think about a chocolate chip cookie, right? Sometimes there's cookie in a bite. Sometimes you get some with a chocolate chip. Sometimes you don't. You never know until you bite in. So heterogeneous mixtures are mixtures that are not well mixed. They do not distribute themselves evenly, no matter how much mixing you may do. So there will always be some variation in the composition in a heterogeneous mixture.